Hi, I'm Seth, and in this video I'm going to show you how to calculate basic descriptive statistics in Excel, including measures of central tendency, measures of variability, and z-scores. So what we have here are data for 27 individuals. They reported how many hours of sleep they get per night on average. So kind of a starting place is knowing the sample size. Now, as I said, there are 27 individuals. I made this pretty easy to see in the data, but you might have a particularly large data set and you might not have an ID column handy. So if that's the case, it's straightforward to calculate the number of respondents. We often represent sample size with N, and we can find it using a formula like equals count, open parentheses, and then highlight the cells that you're interested in. Okay, so we're interested in B3, column B, row 3, through B29. All right, so that's represented like this, B3 colon B29. There are 27 cells, as we knew there would be. So the most popular measure of central tendency is the mean, or the arithmetic mean, which a lot of people know as the average. And the formula is right here. To find the mean, you add up all of the scores, then you divide by the number of scores. So first, let's add up our scores. We can use equal sign, SUM, so sum. So let's highlight all the cells that we're interested in, B3 through B29, and they add up to 187.5. So the mean is calculated by dividing the sum of X by the number of scores. So the mean is equal to the sum slash for division 27. And I get 6.94. If you want to control the number of decimals, you can do that here in this numbers tab. Another way we could have calculated this is using the formula equals average. This gives us the arithmetic mean. Again, highlight all the cells you're interested in and hit enter. And this confirms we calculated it correctly. It's 6.94. Now, you could find the median by ordering these numbers from lowest to highest and then finding the middle value. But it's a little quicker to just use the formula equals median, open parentheses, highlight the cells that we're interested in, B3 through B29, and we get 7. To calculate the mode, let's use the function mod dot single, so mode.sngl. As always, we need to specify the range that we're talking about. So highlight all the cells that you're interested in. The mode is 7. So if you were to go through here and count, the most frequently occurring value would be 7. These are college students, so it's probably not surprising they get fewer than 8 hours of sleep. And the mean, median, and mode largely agree. They're pretty similar. In this particular class of students, it's about 7 hours of sleep per night on average. Okay, on to some measures of variability. To find the range, one thing you can do is calculate the minimum and the maximum. The function min will find the minimum value in a particular range. And the function max will find the maximum value in a particular range. Okay, so these scores range from 5 to 9. Next, let's calculate the sum of squares. That's the sum of squared deviations from the mean. This is an index of dispersion. Here is the formula for sum of squares. It is just like the name says, it's the sum of the squared deviations from the mean. So I'll show you how to get this very quickly in Excel, but first let's work through the steps piece by piece. First, we can find the deviation of each score from the mean, so using x minus m, where m is the mean. Let's put that in this column. We can say this will be equal to, our value of x is 7, and then we will subtract the mean, 6.94. Okay, and I hate the number of decimals, so I'm going to reduce it. It's about 0.056. So 7 is very close to the mean of 6.94. Now in this formula, I'm going to make it so that we stay locked onto that third row. That way I can drag the formula down. Now it'll keep moving from one row to the next, but the value that's being subtracted stays locked into this third row right here, 6.94. So we can grab the bottom right corner of the cell to copy the formula down. And those are our deviations. Now the problem with deviations is that they add up to 0. That's because half the weight is above the mean and half is below the mean by definition, so the negatives and positives cancel out when we sum them. This also means that the average deviation will be 0. Let's check. Average of all these deviations, 0. So that's not a particularly helpful index of variability, and that's why we use sums of squares, variance, and standard deviation. So to get around this problem, we square our deviations before averaging them. To square them, you can say equals, select the deviation that you want to square, then you could multiply it times itself, or you could say it's equal to that value raised to the second power, so up caret 2. Okay, I don't like all those decimals, so I'm just going to drag it to like right there, I guess. And then I'm just going to drag this down, and it's going to do what we want all the way down. Let's check and see. Yep, what this formula says is whatever is to the left of me, square it. So 2.056 squared is 4.225. Okay, so let's add up all of these squared deviations and see what we get. This is equal to the sum of all of these squared deviations. It's 39.67. Okay, that's fine. But if you'd like to calculate that much faster without these intermediary steps, you could say equals DEVSQ. That will calculate your sum of squared deviations. Highlight the values that you're interested in. And we get the exact same answer, 39.67. Next, let's find the variance. The variance for a sample is calculated by taking the sums of squared deviations and dividing by the degrees of freedom, which are n minus 1. So why don't we go ahead and calculate our degrees of freedom real quick. Well, n is 27, so the degrees of freedom are n minus 1, or 26. So the variance is going to be equal to the sums of squared deviations divided by the degrees of freedom. Okay, 39.67 divided by 26. The variance is 1.53, basically. We can calculate this more quickly using the formula var.s. That calculates the variance of a sample. Open parentheses, select the scores you're interested in, and we get the same answer, 1.53 once we round. And here is the formula for the standard deviation. It's just the square root of the variance. So we could calculate this as equals SQRT, that's for square root of the variance, 1.24. I'm just going to round these to the hundredths place. A faster way to get there is to say equals STDEV dot S. That's the standard deviation of a sample. Open parentheses, select the cells you're interested in, and there we go, 1.24. That means we calculated everything correctly. All right, the last thing that I promised to show you how to do is calculate z-scores. Here's the formula for a z-score. It's the difference between the mean and a particular score expressed in standard deviation units. So x minus the mean divided by the standard deviation. Okay, so we can get a z-score for each value of x by saying this is equal to, open parentheses, select your value of x, subtract. Here's our mean, and I'm just going to go ahead and lock that into place so that whenever I copy the formula, it will keep using this value as the mean, close parentheses, divided by the standard deviation right here. And again, I'm just going to lock that into place with a $sign in front of the 3. That's fine. Now notice whenever I drag this down, the first term is moving down to the next row, but we're sticking with the mean and the standard deviation right where they belong. Okay, so let's drag this down for all of them. There we go. If you want to check that you've done this correctly, we could say, well, what are the mean and standard deviation of a z-score? Mean of the z-score, standard deviation of the z-score. Always, the average z-score will be 0, and the standard deviation will be 1. So if you get 0 and 1, that means we calculated it correctly. All right, so that's a quick walkthrough of how to calculate mean, median, mode, range, sums of squares, variance, standard deviation, and z-scores, all in Excel. You know what? I'll give you a bonus. Here's an alternative way that we could have calculated the z-score. You could say standardize. What it will want are 3 arguments. First, it wants your value of x. Then it wants your value of the mean. Then it wants your value of the standard deviation. So we could say, there's our first value, comma. There's our second value, lock that 3, comma. There's our standard deviation. And we're going to, lock that 3 into place. This is going to give us the exact same answer that we got using this formula because it is actually just doing the same thing. It's just another way to get to the same result. And if we copy over, we find the mean and standard deviation are still 0 and 1 because all the values are exactly the same as when we calculated them the other way. All right, there it is, descriptive statistics in Excel. Have fun.